Hello everyone. So in this video, let us see the lead code problem, so-called strong password checker 2. So that is 2299. Which is from easy level. So while creating the accounts, you all know you enter password, right? Okay. So, but while entering the password, we have some constraints down to that field. So that is at least one uppercase character required, lowercase character required, digit required, special character required, minimum length required. So likewise, you observe some constraints, right? Okay. So this program is also from the same thing. So there, while creating accounts, you observed those constraints from the front end. So how these constraints are imposed in the back end? Okay, how users are restricting. To enter at least one uppercase, lowercase, all this. Let us see with this problem statement. Okay, so a password is said to be strong if it satisfies all the following criteria. So minimum 8 characters has to be there, at least one lowercase required. So in Python we have is lower. So for checking the lowercase character, and for checking uppercase we have is upper. Okay, and it contains at least one digit. For checking digit we have is digit. Method. Next. So for checking special characters, directly we don't have any inbuilt method. So, but with the help of allnum, is allnum, we can check special character indirectly. Okay. So, but it's not required here because observe the next statement. The special characters are the characters in the following string. Already, so they given one string of special characters here. Okay. So only we should check whether the character is matching with any one of these or not. If matches, as we considered it, it contains the special characters. No inbuilt methods are required for this. Okay. And apart from this, one more constraint condition is given here. Okay. So that is, it does not contain two of the same character in adjacent positions. Okay. That is, observe here, AAB violates this condition. Continuously you can observe the two characters common here, but ABA does not, because here also you can observe a character is repeating for twice, but it's not appearing in continuous form. Okay, so I hope you understood this constraint. Okay, regularly, for comparing with the adjacent positions, we run loop up to the last but one position, because if we run up to the last position, we may get index error. But here it's required to run the loop up to the last position, because we need to check the remaining characters, right? Okay. So then how we can avoid that index error? So how we can check up to that last position? So I'll explain now. Okay. So here, the password is given return true if it is strong password, otherwise return false. Okay. So observe the examples here. So here the minimum length is not satisfying. Contains uppercase, special characters, lowercase, digit, everything. Okay. Here length is satisfying, uppercase, lowercase, everything you can observe here. But it does not contain any digits, and contiguously you can observe the two characters here. Okay, and here it satisfies every constraint: uppercase, lowercase, digit, special character, minimum length, everything. Adjacent, there are no characters. Okay, so here. Read these hints, you can understood one thing. In this program, let us discuss flag approach form. Okay. So that is initially I'll take the four flag variables, so called uppercase, lowercase, digit, and special character. Okay. Initially I take the all characters to all variables to zero. So the meaning of that one is our string may not contain one at least one uppercase character, or else our string may not contain at least one lowercase character. So likewise, okay, I hope you understood. In the hint also, it's given the same. Can use a Boolean flag to define certain type of characters in the string. So our assumption should represent with the flag variables by initially taking to 0. For suppose if we found any uppercase characters, we turn that uppercase flag variable to 1. So if we may get a number of uppercase characters, again and again we turn it to 1. So there is no problem in it, okay? Uh, so after completion of the traversing, so the entire string, so we need to check one thing here. So whether all Boolean flags have ended up true or not, okay? So if all variables so converted into one, so then only we should consider that it's a strong. And do not forget the check adjacent and length. Okay. But suppose if length itself not matches, okay, it's not required to check so uppercase, lowercase, all this, right? There itself you can stop. So same thing you are going to observe in the program now. First I'll check the length. If length satisfies, then only I'll start so checking the remaining characters. Okay. So observe this now. Let us design the program. Strong password checker 2 method given, password string given, and so we need to return the Boolean type. Okay. So first, let us check the length. Okay. So n is equals to length of password if n value is less than of 8. So there itself you can stop and so return false. Okay. So it's not required to work with remaining. If not, so I'm taking the four flag variables here: uppercase, lowercase, digits, special characters. Initially, I'm taking the all variables to zeros. The meaning of this one is string may not contain any one of this. Okay, so I'm taking all these to zero. Now let us start generating positions of string. So next. So let us check one by one. For suppose if password of I, if it is lower, if we got lowercase character at any time, so I'll turn lowercase flag variable to 1. So likewise, let us check the remaining conditions. Okay. For suppose if I got uppercase character, I'm checking with is upper now. Okay. If it is Java, use is lowercase, L uppercase, and C uppercase, is uppercase, U uppercase, and C uppercase. Okay. Uppercase flag variable I'm turning to one. So next, else if password of I, if it is digit. Okay. Checking with is digit method. So digit flag variable I'm turning to one. Next of all, if password is a special character, see here I'm checking with in operator whether let us copy this. Let us copy this string now. And so if characters so matches with any one of these characters, so then special characters turns to one here. Okay. So it is actually five conditions we covered, okay? Checking length and next of all, uppercase, lowercase, digit, and special character. We are left over with one condition that is adjacent position characters. See here, observe this carefully. We should not use elif here because for suppose observe this example. First example, AAB. So here these are uppercase characters, right? Okay. If it is uppercase character, so if this elif block executes, okay. So do this elif block is going to execute, that is going to check for adjacent position characters. We need to check adjacent position characters, right? If you found adjacent position characters are matching, there itself you can stop. It's not required to check with the remaining things, okay. So that's why might be up lowercase condition becomes true, uppercase condition becomes true, digit condition, or else any of these of condition becomes true. Irrespective of this, contiguous position characters has to be checked. That's why I'm using if here. So I hope you understood. By avoiding if, take elif here. So check how many test cases so failed. Okay, all these go through. Okay, what we need to check? So current position character, we should check whether matching with the mm, adjacent position character or not. If matches, there itself stop and return false. Okay, so here, while what I said, while comparing with the adjacent positions, we should check. So we should not uh, allow this condition to be checked for the last position. Okay, so means for n minus 1 position, this condition has to be not executed. So for that sake, what I am doing here, so I am taking so the condition called I less than n minus 2. So I less than n minus 1. So this one works at up to n minus 2 positions. So but fails for n minus 1 position. So whenever it reaches to n minus 1, this condition becomes fail, right? N minus 1 less than n minus 1. So that it won't goes for checking so the right side one. You know the shortcut of AND operator. If left side becomes a false, it won't check the right side condition, right? So in this way, we can avoid so checking adjacent position characters here. Okay. So with this, we completed so checking everything uppercase, lowercase, digit, special character, length, and next of all adjacent characters. What it is here? After completion of so everything, okay. So check all these flag variables turned to one or not. Okay, lowercase to one, uppercase to one, and so digit to one and a special character to 1. So if all these flag variables turns to 1, okay, so then returns true. So if any one of these flag variables so not updated to 1, okay, in that scenario control comes to the else block and returns to the false, okay. So this is the strong password checker program. Okay, let us run and so check. 1 minute. So we got some error here. Okay, so here we taken this password here. It's a length, right? Okay, it's good. Fine. Check. So base test cases executed here. Let us submit now. Yeah, it's working fine. Okay. So I hope so each and everyone understood. Okay. So this is a real-time program. Okay. So that's it. So thank you. Thank you everyone. Let us meet in the next video.